some technical difficulties in the beginning. Sounds good. So thank you for introduction and welcome to the session. It's not an AI session. I don't know if it's good or bad. Is it relief or disappointment? If we may have an AI demo, we'll see how we go when we get there. And a little bit in the way of introduction. So I'm Olga, and I'm lead platform engineer. And I've been in the platform and cloud space for a few years now. I've been working in large financial services organizations and in pure tech, such as Intel and Red Hat, worked across multiple clouds in my career. And in the past few years, I've been heavily focused in Kubernetes, runtime, security, and this will be the focus of my talk today. So as my talk been accepted, I opened the documentation to start working on the slide deck. And the first thing that I've discovered, there is a page for that. And not one, but two. There is one on Google GKE side and one on the Cloud Run, how to migrate from GKE to Cloud Run. And then I thought, okay, amazing. I'll just send you the link and give you your 40 minutes back. But as you may expect, it will look something like that. And needless to say, this is not how things look in the real world. It's a little bit more complex than that. And don't worry, there's plenty to talk about today in this session, despite these pages. If you haven't seen Cloud Run before, then look at this manifest that you see on the left-hand side. This is how the Cloud Run service looks like. It's all about your application, about the software that you carefully designed and wrote, and then you package this as a Kubernetes, as a manifest, and all that you want to do now is to just deploy it and let it run. So at the heart of your Cloud Run service is your application. Then you give some parameters how you run it, the ports, environment variables, and other configuration things. There is a little bit more to that in the world of Cloud Run as well, but overall it's a lot shorter than we used to do in the Kubernetes world. Okay, to set the stage about what we're going to talk today. So again, I'm going to talk about the services, but not the Cloud Run functions and jobs. Services is the most direct translation between your Kubernetes deployment and into like the microservices architecture on the Cloud Run. So you'll use the services. Services have ingress, and this is what makes them interesting, because ingress is something that we definitely want to secure and be aware of. And yeah, as I said, I'll be talking about security and the networking. Obviously, in any migration or in any system design, there is a lot more. There is heaps of other aspects, but we just don't have time to cover everything. And as I'm talking, I'm not just talking about migrating a single application from one place to another place. We are going to talk about completely rebuilding our estate on another platform. And that means you want to be secure, compliant, but at the same time, you also want to strive for that secure as practical level. Take a risk-based approach and secure as much as you can and as much as makes sense. You can't strive, and you shouldn't be striving for 100% security, because the only application that is 100% secure is the application that doesn't run. And we still want to run applications and deliver some value to our customers. And yes, there will be technical deep dives. There will be mention on a few technologies. There will be some details, but I also zoom out at some point and we'll talk about why we're doing things that we are doing, what are the system design principles. So I hope that everyone can learn something new from that session, regardless of where you're coming from. And I know there is a range of skills here. Some people are on the start in their careers, other people like senior, but in like Android development and other backgrounds. Okay, so why do we go to Cloud Run in the first place? So this is the higher level, more managed platform. We all know Kubernetes is hard. there is so many things that you need to know. You need to tune them. You need to make sure they're secure. And there's just too many knobs you need to configure. And there's also cluster upgrades. And even if we are talking about platform like GKE, which is very highly managed, very opinionated, very highly integrated into the Google infrastructure ecosystem. And even there is still a lot of work that falls on the shoulders of platform engineers that need to maintain the system, and they also need to expose it to our internal customers, which are software developer teams. On the other hand, the next level is that we go to the more managed platform, which is, in our case, is the Cloud Run, platform as a service. Cloud Run abstracts away all of that complexity and gives you this nice user experience. And this developer experience is where Cloud Run really shines. It's really all about focusing on your application and handling everything else by itself. And the quotes that you have here on this screen, it's the quotes that come in from people in the industry that actually have a lot of experience with Kubernetes, with software engineering, and they are voicing not just their opinions, but the opinions of the software engineers that they work with. And they just say, like, look, it just feels more managed, even if they can't explain exactly. Even in the organizations where you have very focused or like very comprehensive platform engineering, or who have dedicated teams for managing Kubernetes, dedicated teams for building internal developer platform, automation, workflows, and even there, you will still, this is a bit better, and even there, you will see that people appreciate the simplicity of Cloud Run. Yeah, so you give the image, give a few parameters, and you get your URL back. And URL looks for your main Cloud Run URL for the service look like the service name, project number, not the ID but the number, and then .run.app URL. But then if you look closely at these .run.app URLs, all of these Cloud Runs, they deployed into Google infrastructure. This is managed service. They're deployed somewhere where you don't have control over. They give you this URL. They scale your instances seamlessly behind that URL. You get this managed experience. Everyone is happy except for security people, because they don't like that by default you have the URL, and this URL, technically, you can call it. From Google perspective, all of this is deployed in production. For you, you have this developer project number, or you have production project number, and on the surface, it seems like you can call from one place to another, and there is no real network segregation that you have control over. So that connection line, it causes a lot of anxiety for people who work with security. And anytime that you see this line that connects to things that you don't want them to talk together, then we instinctively reach for firewall, and we'll explore the firewalls as we go. Look, let's explore a bit deeper. What is this .run.app URL? If you try to resolve it, it resolves to public IPs, and you'll have 9 records. All of these public IPs, they come out of the list that Google, that it's not even Google, but they are published on the internet. You can find this list. This IP is reserved for Google, and they are one of the many ranges that are inside the same list. And that also, as you can see, these ranges are really big, /10, /11. This one is has more than 4 million IPs in it. So it is massive. So for the purpose of firewalling, it's pretty useless. You can't do anything if you want to do it based on the IPs anyway. And one note on this is that despite it being public IP, if you do configure this to route internally, it will route internally without going to the public internet. Now let's remind ourselves how things work in Kubernetes and what Kubernetes is. Generally speaking, Kubernetes is nothing more than just a pile of VMs. These VMs, they run software on top of them that make appear these VMs as some large, coherent, elastic platform to the tenants that run their workloads on top of it. So you'll find a VM, and it runs applications from multiple tenants on the same shared host, on the same shared networking resources. And some of these containers might have weaker security posture. And if one of these containers are compromised and the attacker managed to get control over the container, they can then break out to the host, the container escape, and move laterally to another container, and possibly get access to the container that handles more sensitive information or has more access to some external resources. Just escape and move laterally until they find something that is really creates the damage. And as a side note, having another node is not a security boundary. The node pools are good for some reasons, for other purposes, but not for the security. In the Kubernetes, when you break out of one container, you can break out to any container on the node. But if we look at these VMs in the world of Kubernetes, they will be hosted inside one project, and typically inside one subnet. Now we have multiple subnets. Kubernetes can support multiple subnets, but our typical web microservices applications, they will live within the same project and one subnet. So all the tenants that you expose your Kubernetes cluster to. And more importantly, you'll have production networks, which is typically should be very cleanly and very strictly separated from non-production networks. And these lay out completely different in the world of Cloud Run. So keep this picture in mind. You have, on one hand, you have all of these multi-tenanted workloads within the same infrastructure and the same project, but at the same time, you have the clear segregation between prod and non-prod networks. Now, because Kubernetes has all of these challenges to work through, they have different mechanisms how they still support the multi-tenants and still maintain security. So through through the mechanisms such namespace, network policies, RBAC, security contexts, and other things that allow you to box each one separately and control the access on the control plane, data plane. But let's try and think of how we translate these concepts from GKE to Cloud Run. So first one is easy. We know that deployment becomes service. There's no confusion there. But when we think about namespace, like what namespace becomes now? How do you take your workloads from one place, and now how do you think of them in the target platform? What will it become? Will it be a project? Do you give each pillar in your organization a project, or each team, or each product? Do you give them a separate project, or do you give them a separate subnet? Now, how do we scope and think about our applications and the application boundary? Now, one thing is like labels. I can tell you, don't do that. Labels are not for the data path or segregation. They're good for things such as FinOps, but in terms of security, they are not security or networking or segregation on the data path. They are not the right tool. The network tags, on the other hand, is the security tool. It allows you to reference a network interface in the firewalls. So think of it as a label, but the label that you can use in the firewalls. And that's basically the only use for the network tags. And now maybe the most important question now, what do we do about network policies? And to answer the network policies question, you need to answer first, what is the application boundary? How do you define these entities who are supposed to talk to each other or not supposed to talk to each other? So there is no clear translation there, but intuitively, I think people would think about network policies as equivalent of firewalls. And network policies, sometimes they would refer as firewalls in the world of Kubernetes. So now we don't have the world of Kubernetes. We are in the big open of the GCP cloud. So let's try and see if firewalls is the right answer here. First of all, the ingress direction for Cloud Run just doesn't work. I mentioned previously that the Cloud Runs are deployed into Google infrastructure that you don't have control over. And they don't have a lag in your VPC, so you can't attach a firewall there. Even if you force all the traffic to go internally, it doesn't give you this lag on the VPC. It only inspects where the traffic coming from. If it's not coming from your VPC, it will throw it away if you configure it with internal setting. We have better luck on the egress. With direct VPC egress, you can force your traffic to go through the VPC, and they apply all of the traffic controls that you have on the VPC level, including the firewalls. And what you can use for firewalls there is you can use the service account, which every service has a service account, but only one. It's the identity. You can't have more than one. Network tags. Here you can specify the groups of Cloud Runs. You can say these Cloud Runs have access to egress paths. These Cloud Runs, like egress to database, they can have access to the database. And you can also layer them and use multiple on the same instance. What you can't use in the world of Cloud Run is the IP. And this is because all the Cloud Runs that are deployed into that egress to the same subnet, you don't get the guaranteed IPs or the blocks. They all be random. So you can't segregate one network, one service from another service based on IPs. Okay, but even if you said, okay, I understand I can't do ingress, but let's try and do the granular firewalls, at least on the egress path. It's still better than nothing. But then you hit the limits, especially at scale. And these limits are not advisory. They're real hard limits because they affect performance, so you can't increase them even if you really want and even if you ask really nicely. There are limits. Then IP-based policies, as I said, only the subnet range. You can't do them granular. And even if you wanted to do automation to live alongside the lifecycle of your Cloud Run, this automation will have to have permission on the shared VPC, which is also it's a very big step. The shared VPC exists for the reason that to segregate this permissions from the network team and the service team. So it's not really great, but it also will explode at scale. As more services that you add to your estate, you'll have to maintain more connections. Okay, so I hope that I've convinced you so far that trying to do firewall policies the same way like we did network policies in Cube, it's the same like as fitting square pegs in round holes. They just were not made for each other. And generally, if you work on a highly managed platform and you find yourself solving problems like that in that situation room over there, you're probably doing something wrong. You're fighting against system, instead of leveraging its strengths. And luckily, we are not Apollo 13 crew, and we are not dealing with life and death emergencies, and we have more at our disposal than only these. So we've been talking so far about all of these roads from one place to another place, focusing on how we secure this path. But then what happens here on this Cloud Run world, we don't have these paths. We don't see them. They're abstracted away from us. So we don't have these roads. And what we need to do instead is that we need to focus and shift our focus from the A to B and how we secure that. We need to shift it to focus on identity. This new Cloud Run world and generally even broader GCP ecosystem and the cloud now moving more towards the identity rather than location or the origin of your request. And in Cloud Run, the key mechanism how you achieve this is the invoker check. The receiving service will list the service accounts that it accepts requests from, and it can be anything that can prove that they own a GCP identity. It can be another Cloud Run service, it can be a VM, it can be a user, basically anything that can prove that they have this service identity, they can call this service. And if not, then the invoker check will reject it. I'll show this quickly. The metrics that you see here is from observability metrics from the receiving service. The first one is where I hit this service with requests with valid credentials. So it has 200. It has an active container that serves the requests. And you can see there is CPU usage that actually container is up and running and serving this request. But when I swap the credentials to something that is not valid, then you can see that the requests are still counted. You can see them. They're coming towards your service, but your container is blissfully asleep. There is no vital signs from your container. So not only you're not exposed to the attack, you're also not paying for the time that someone trying to knock on your door and do something nefarious possibly. And so you can see how that IAM world is translated basically also to network access. You don't have the attacker didn't get the access to the container, not a single line of code of your application code was executed during this for these requests. Okay, let's recap for a moment. So we've seen that the firewalls are treating Cloud Run, but we've also seen that reaching the service on the network doesn't actually mean that automatically you have access to the container. And this is great from the security perspective because you basically eliminate the whole class of attack surface of the escape to the container and escape to the next like lateral movement. The question though, are we on the right path really? We've been focusing on translation from here to there, but what we really want to do here is we want to build the new world, our systems, our applications on the new platform, and we want to build it on zero trust architecture. That means basically never trust, always verify. This is the mantra of the zero trust. Always assume that your perimeter is breached. Always assume that something's going on. You can't trust request only because it comes from internal network. Now, I want to stop here for a moment and just say, this talk is not a permission to not do firewalls. You absolutely need to do firewalls. My focus here is to do them right, to do them in correct granularity, and always layer them and have defense in depth. The proper firewalls at the boundary of your network, so whatever makes sense, the access to certain resources, absolutely do that. This is one of your layers of security. Other security mechanisms that you have, the organizational policy, similar to gatekeeper policy, you can prevent people from deploying insecure configurations, such as you can enforce that all Cloud Runs have internal ingress, for example. And yeah, just a moment also on identity as the new perimeter. This is relatively new concept where you inject the GCP IAM onto really the data path, the traffic that really flows between your services from the users into your class, so into your Cloud Run, and you actually offload to the GCP infrastructure to do this check for you, and then block the networking access based on that. So you have identity-aware proxy and secure-aware proxy. There's two main products that do that for you. Otherwise, you'll have to do this authentication by yourself. You need to do this in-app authentication or whatever and decide it based like within the app. But now you actually, like we saw with Invoker here, you offload this to another layer, but you still achieve the network segregation or network control. Okay, and going back for another moment to the Kubernetes. Kubernetes runs on shared infrastructure, multi-tenanted workloads, and it achieves all of that. It gives you all of the tools to achieve any level of security that you want. And it also, keep in mind the timing of the Kubernetes, that it was available for us a lot earlier than the cloud runs, so any serverless platform. So the shared, again, it's deploying this multi-tenanted workloads so that you don't know where they're coming from, maybe, or from every walk of life, and you support any tenants, and you run on the shared infrastructure there. But Cloud Run shared infrastructure is one problem that Cloud Run doesn't have. Every container runs in essentially in a VM. You have the syscall filtering, and you have no shared node to escape. Even if you manage to bypass all of this isolation and filtering, then you just simply don't have any other node where you can escape to, and there is no container next door. Then about the ingress infrastructure, you have a number of layers that Google sets for you to protect your container. Google front end is that layer. It's the massive distributed infrastructure that Google runs on the edge. Any request that originates in the internet and comes to your service, or any service for that matter that run inside Google Cloud, they will first meet Google front end, and they mitigate a number of network attacks. They do lots of stuff there. There's one of the biggest attacks on the record was 4 million requests per second at request that was mitigated by Google front end and protecting the customers inside. Now, important to mention, every request now is terminated by Google front end and then proxied inside. And the IPs that we've seen before, this invoker check, this is actually doing the invoker check. This is the snippet of curl command where you don't have the valid credentials. So you'll see it will say 403, and it is served by Google front end. The 200s will also have the same header that's served by the Google front end. And finally, I don't want to spend here too much time, but you can disable you can disable the default URL and bring your own domain. So you have control over your branding, and then you do all the traditional edge stuff. So you do the external LB, Cloud Armor, which is a WAF, and for the purpose of Cloud Run here is that you can actually disable this URL if you don't want it, but only do it for the services that you need to expose externally. Okay, and now I hope that the demo works. Let me try and see if everything is up and running here. Okay, so first of all, what I wanted to show is, let me double check what's going on here. Okay, so let's look what we want to talk about. What I wanted to show here today. So we have an AI stack here. We have a Gemma application, which is packaged by. It's actually Gemma is the open source model that Google publishes. You can find it on multiple sources, but you also have a publicly available image that has the model, but also the inference layer that allows you to just deploy this and use it as a LLM, basically. And we have N8N framework, which allows you to build workflows, especially powered by AI. So you can build the workflows and put the steps that talk out to AI using MCP and memory and all other things that we've been talking about. Other speakers today mentioned before. So I have the Gemma only available on Gemma is available only internally, and N8N is available on internal and external. And I'll make it a little bit bigger. And what we see here, I'll give you an example here. So this Gemma is this. Oops, it never works when save. No, I don't want to save it. Okay. So let's try and call this service. Gemma is available. How do I get there every time? Okay, I'll do it in the easy way then. I'll remove this authorization header. And this is what you'll see, the response that you've seen before. Let me get it a bit bigger and up to the screen. So here's the global front end that got us the 4.3 request before. And again, if I call it with the header, with the invoker check that allows that actually allows us to call that service, then you will see a response. Now, what we've been doing here, I've provided the prompt in the request. This is Open API payload. Why everything is so slow? Because I'm not typing it correctly. This is basically the minimal request that you can put to your model. So specify which model it is. You specify the question, and then what you get out is that this file that we just got out of this request that I sent manually. Okay, now if we try. Give me a moment to take it back here. So now this is the Gemma model Cloud Run. This is the full manifest, how that looks like. So this is I'm telling the traffic to go through the VPC, to not go through the public internet. Then you'll see here, this is the model. This is the container that runs the model, but also the inference layer, so that you can interact with this directly. You can specify the GPU, but not in Australian region. There is only four or five regions where you can run GPUs, and that's about it. So you'll have the revisions and just a bunch of other parameters, and you see it's a lot of easier than it is for the Kubernetes world. Now for the networking, this is how that will look like. This one, because it's only accessed from internal network. I say it's only exposed internally, but not even from load balancer. And the VPC is for egress traffic. On the other hand, for the N8N, this is something that I want to expose for the users, for them to build the workflows. This would be exposed through the external application load balancer. Now, let me see if that is still alive. and it's not allowing me to connect. This is what happens with the demos. Let me just try to do it once again. I'll delete this model, restart everything, and try this again. Olama, create Olama account. We'll create a new one. I'll go get Gemma URL. This is the URL that we've been talking about before. So you see it's just the name of the service, the project number, your region, and that's it. But it's not available to be accessed from the internet. Now I'll go and I'll try to put this once again into here. This is here. Let's see if that works this time. No, okay. So that part of the demo didn't work, unfortunately. I don't understand why it just worked before, and I have some witnesses here. But for the purpose of the Cloud Run security and the network segregation, I think this is what we wanted to cover anyways. Unfortunately, this section didn't work, but we did see how that looks when you do provide credentials. So you don't do credentials. Let's try another one. So again, showing you how that will look like here. Even though it's only internal only service, you can't hit it from the internet. You will still get these addresses, and these are the Google global front-end addresses, but you don't need to worry that they're public. They're still run privately inside the cloud. Okay, so demo didn't quite work. I'm sorry for that, but it's basically doing the same as the curl that I just showed you before, that sending some requests, basic prompt, and getting the request, getting the payload out. But we are running out of time anyway, so let's go back to the presentation. And yeah, it's basically just to wrap things up. So we've been talking a lot about the Kubernetes luggage, what Kubernetes is achieving, and what's the challenges that Kubernetes has. Lots and lots and lots of resources and configuration that we have in the world of Kubernetes. And now, how do we actually translate this to the world of Cloud Run? And I hope that if you really were paying attention, that the answer is that we don't. We don't translate. We spend time understanding what is the target platform, understand the philosophy behind the platform, what problems did it solve for us, why did it solve it the way it solved, and understanding just the ecosystem, what's the underlying overarching and like high level design principles that is going into the platform itself. And then you want to understand the requirements of your own business. What do you want to migrate? What kind of applications, what kind of security do they need to adhere to, and what kind of resources do they need to connect to? And only then layer this with the design principles, zero trust, security, defense in depth, and only then you start building your target world, and then you think about how you actually execute this migration from previous to the next world. So that's all that I had for today. And if you have questions, you're welcome to connect with me and talk to me afterwards. And the slides will be available probably on the conference website, but also in my GitHub pages. And this is it. Thank you.